How's everybody doing out there? Well, now that we've talked about how to look at descriptive statistics with kind of a graphical approach, now what we want to do is look at some numerical ways that we can describe different statistics. So in this section, we're going to be talking about measures of location. So what we're going to be looking at particularly are percentiles and where exactly is the data related to its different percentile that's actually given. So if we look, the way we're going to actually calculate our percentiles is we're going to find a location. So this I that we're looking at is actually just the location of where our percentile lives in relationship to the data. So it's not our answer, so keep that in mind. So this is the location of our percentile. So once we have this percentile, one of two things is going to happen. So if we're lucky and our I turns out to be an integer, then we just count along our list of data until we get to where that integer is, and that number exactly is going to be related to that given percentile that we have. If it's not an integer, which is more likely what happens, then in the second case, what we want to do is kind of round that number down, round that number up, and we're going to use those two locations, figure out where both of those numbers are on our list, average them together, and that number will be where our number exists on our percentile. So it'll make a little bit more sense when we're actually working through them. So let's go ahead and take a look at our example 1 here. So in this case, we have our list is given to us in terms of a frequency distribution. So it wouldn't necessarily have to be a frequency distribution. It could just be a long list of numbers. But if it is a long list of numbers, what we want to make sure is that our numbers are ordered from lowest to highest. And so I'm going to show you a little trick later that you can do with your calculator to do that for you. So that way you don't have to do it all by hand. All right. So what we're looking at is we're trying to find the 28th percentile and the 80th percentile of our set of data here. So the first thing we need to figure out is what's the location of our 28th percentile. So our K in our formula is going to be our percentage as a whole number, and our N is the number of elements that we have total in our list. So with this one, what we've got is we've got 50 college students. So our N is going to be 50 for both of these problems. And for our 28th percentile, we're going to let K equal 28. So if we plug this into the formula, we're going to get 28 over 100 times 50 plus 1. And then if I throw this in the calculator real quick, it looks like I'm going to get 14.28. So since our index number is not a whole number, then this means we're in case 2. So what we need to do is we need to take that 14.28, round it down, and round it up. So what we're looking at is we want to figure out what number lives in the 14th position and what number lives in the 15th position, and then we're going to average those two together to get our percentile. Now the way the frequency distribution works is what we want to do is kind of add up our frequencies along the bottom so we can figure out where our 14th number is on our list and where our 15th number is on our list. So if I notice where I drew this little line, so there's only 2 values below that number because our frequency is 2. If I go up to here, then I've got 2 plus 5. So that means that the 7th number in our list is going to be a 5. And so if I go up to the next position, 2 plus 5 plus 7 is going to give us 14. So what that means is the 6th number, or the number 6, is the 14th number on our list, and it's the last number before we jump to the next position over. So in this case, our 14th position is going to be our 6. To go to 15 means we're going to go up one more, which means we're going to jump into that 7 column. So our 15th number in our list is going to be 7. All right, so now that we figured out where each of our numbers are on our location, now it's time to average them together to get our percentile. So we're going to get 6 plus 7, all divided by 2, equals 13 divided by 2, which is the same thing as 6.5. So the 28th percentile, so the number that's located at the 28th percentile on our data list would be 6.5. Now you may be asking, well look, the data above doesn't even have any decimals. They're all whole numbers, 4, 5, 6, 7, 8, 9, 10. And that's okay. So our percentile doesn't necessarily have to be one of the numbers in the data set. It's just letting you know if you were to divide this up into groups, that's exactly where the division would be between the lower 28th percent and the upper 72nd percent of data in that case. So 6.5 is totally valid. That's good. All right. So let's take a look at our 80th percentile. So again, we want to do the same thing. So in this case, our K is going to equal 80. So we're going to get 80 over 100 times 50 plus 1. And so again, typing this in our calculator. So I'm getting 40.8 is our index number. So again, what I want to do is round this down and round this up. So the two numbers that I'm looking for on our list, I'm looking for the 40th number and I'm looking for the 41st number on our list. So let me erase these real quick here so we can start over with our adding. All right, so we know up to this point, we knew we were at 14. So what we want to do is just keep adding until we can figure out where 40 is located. So if we go up 12 more, we're going to be at 26. If we go up 14 more, we're right at 40 again. So what this means is that that number 8 is going to be the 40th number on our list, and it's also going to be the last number before we again jump into the next column over. So with this one, our 40th position is going to be the number 8. The 41st, we're going to jump over to the next column, so that's going to be our 9. So now to find our percentile, same thing, we're going to average these two together. And then 17 divided by 2 is going to give us 8.5. Excuse me. All right. So does that look good for our percentiles? All right, perfect. So the most important kind of percentiles that we're actually going to talk about are what are called quartiles. And so again, these are going to be still just related to percentiles, but these just have special percentages. And if you can imagine, quart or quartile is going to be related to 25% and things like that. So these are broken up into 3 different quartiles. So we're going to have our first quartile, our second quartile, which is sometimes also called the median, or the third quartile. And so you can see these are denoted Q1, Q2, and Q3 respectively. And so the first quartile, what its job is taking and dividing the data up into the lower 25% and the upper 75%. So if you were thinking about this, all the data kind of being laid out on a number line, then Q1 is going to be this little section down here, and it's going to be where this divides. So it's going to separate where the lower 25% exist from the upper 75%. All right, so our Q2 is really just going to divide the data in half. So we're going to have 50% below, 50% above. So again, if we were to think of this from kind of a number line perspective, so our Q2 is going to live in the middle. And so 50% of the data lives above, 50% of the data lives below that number. And then finally, Q3 is kind of the opposite of Q1. So in this case, it's going to be over here. And so the top 25% is going to live on the right, and the lower 75% is going to live on the left. Now, in terms of calculating it, we're still going to calculate it just like it's a regular percentage, except in this case, we're going to be using specific values. So for Q1, our percent's, of course, going to be 25. Q2, our percent's going to be 50. And then for Q3, our percent's going to be 75 for each of these. All right, so let's look at an example and find these quartiles, or these quartiles for the following example. So notice this one's not given to us as a frequency distribution, it's just given to us as a long list of numbers. And it's important to note that these numbers are ordered lowest to highest. So if they weren't ordered lowest to highest, that'd be the first thing we'd have to do, is change these around, order them from lowest to highest, and then we can go ahead and calculate our index for each of these. So again, make sure your data is always lowest to highest. All right, so for our quartiles, so we've got our K for this one is going to be 25 for our first quartile. And so if we look, we first have to figure out how many exams do we actually have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our N for this is going to be 20. So now let's go ahead and figure out our index for the first quartile. So I equals 25 over 100 times 20 plus 1. And so throwing this in the calculator, I got 5.25, which again, unfortunately, is not a whole number. So again, we're going to have to do our round down, round up thing, like we did last time. So we want to figure out what number lives in the 5th position, what number lives in the 6th position, and then we're going to average those two together to get our quartile, first quartile. So if we count over, so 1, 2, 3, 4, 5, so 57 is our number that's in the 5th position, and so 58 is going to be our number in the 6th position. So again, let's average them real quick. So 57 plus 58, all divided by 2, is going to be, what, 115, which should give us 57.5. Took up a little bit too much room there. All right. All right. So that's our median or that's our first quartile. So that's again, so that's going to live here. And so the idea is 25% of the data lives to the left of there, 75% of the data lives to the right. So again, that's what this means if we think about it from kind of a number line perspective. All right, so let's calculate our median. So this is going to be the actual middle of our data. So for this one, we're looking for K equals 50. So our setup's the same. So 50 over 100 times 20 plus 1. And so if we type this in, we're going to get 10.5. So again, another decimal, so we're going to have to take our lower number and our upper number, figure out where they're located on our list. And so with this one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 62 is our 10th position. 63 is our 11th position. So again, let's average these together. 62 plus 63 over 2 equals 125, which is going to give us 62.5. And so again, between here and here, 50% our data is going to live to the left, 50% of our data is going to live to the right for this one. So this would be where our Q1 lives. There's our Q2. All right, so finally, third quartile. So we've got K equals 75. So again, let's calculate our index first. So throw this in the calculator. We get 15.75. So again, not a whole number. So we're going to have to round down and round up. and figure out where each of these are position-wise. So we know 62 was 10, so 63 is 11, 12, 13, 14, 15. So 74 is going to be our 15th number, and then our 16th number is going to be 75. So again, average these together. So 149 divided by 2, so we're going to get 74.5. So again, finally, our Q3 lives there. And so what that means is we've got 25% of the data lives above that Q3, 75% is going to live to the left of Q3. All right. So if you have any questions or anything about that, definitely let me know. I've got tons of practice problems for you guys to work on, so don't worry about that. All right, so the last thing is, so these quartiles are so important that they actually get their own name. And so in this case, what they're actually called is the 5-number summary. And so if you ask, it's like, well, these are only 3 numbers. So what we're doing is we're actually throwing in 2 extra numbers that we haven't used at the moment, but they're easy enough to find. And so what we're throwing in is the min and the max. So what we're doing is just looking at the smallest number on the list and the biggest number on the list combined with our Q1, Q2, and Q3. And those are going to give us what's called the 5-number summary. So again, this is a nice way to think about the data because it lets us know what the smallest number is on the list, what the biggest number is, where the middle is, and like where our different 25% are as well. And so in the next section, we're going to be talking about a thing called a box plot. And so we're going to be using this 5-number summary as a way to calculate our box plot. All right, so let me just summarize what we've done here in example 3. So what we want to do is actually just list our 5-number summary. So we've already done the Q1, the median, and the Q3. So we just have to drop those in here. So 57.5, 62.5, and 74.5. So the only thing that we haven't figured out yet is, of course, our min and our max. And since we have these in lowest order, so of course the min is just going to be the number that's on the far left. The max is just going to be the number that's on the far right. So we can throw our 47 in for our min and our 95 in for our max, and we're done. That's our 5-number summary. All right, so I'll have you guys practice the next practice problems. Again, I'll have you post some answers just to make sure everybody's on the right track. So I'm going to, in a separate video, I'm going to show you, because notice in practice 1, these numbers aren't necessarily given in order. Now, I did say you could use the frequency diagram that you made in section 2.1, which is totally fine if you want to use that. But I'm going to make a separate little video to talk about how to take a set of data, enter it, and then reorder it so that it is lowest to highest, so that way you can use these calculations as well. All right, so good luck. If you have any questions, just message me on the app.